Okay, start reading 50, MCQ number 58.
A motorboat vibrates in the water so that it produces water waves of frequency 0.20 Hz. The speed of these waves in the water is 20 meter second negative 1. The motorboat moves with a speed of 5.0 meter second negative 1 directly towards the stationary sailing boat. The Doppler effect equation for sound waves also applies to water waves. What is the frequency with which the waves hit the stationary sailing boat?
So here they have did one thing. They changed the sound waves to water waves. They are saying that Doppler effect also applies to water waves. So now the formula would remain same, but the something would change. What? Instead of speed of sound, we will be taking speed of water, right?
Yes.
So they have done this thing in this question. So the frequency of the observer we have to find, right? They're asking what is the frequency which hit the stationary sailing boat. So you can hint by the stationary word that it is the observer, the sailing boat. So it is equals to frequency of the water, which is 0.20 fs multiplied by v, which is the speed of water, 20 over 20. And if it is towards, so you have to subtract it towards minus the speed of the motor, which is 5. That would be your solution. The formula is F over Fs V over V minus Vs. Now tell me the answer. Is it clear?
0.27.
Yes, right. So is it clear the working?
Yes.
So the next question is 59, which is saying infrared laser light is used for transmission data along optic fibers. What is the typical wavelength of infrared radiation? So again, I told you I will provide you a table. So in the table, the values are written in the exponent form, like exponent minus 11 or minus 9 or minus 7. So if you memorize it, you will easily solve this question. So the answer is A. So don't worry, you will just memorize the table. You can be easily be able to solve these questions. But the questions are like this, okay? Solve.
Okay.
Now read this question.
A sound wave reduces in intensity but maintains a constant frequency as it travels through air. Which statement is correct?
Which statement is correct? The maximum displacement of the particle changes between one particle and the next particle. The maximum displacement of the particle changes between one particle and the next particle. So if you are reducing the intensity, so yeah, you can say that if the intensity is decreasing, so you know we studied the relation intensity is directly proportional to the square of, remember?
So intensity, the formula is P over 4 pi r square, right?
No. The intensity depends on the amplitude as well. I'm asking for amplitude. So revise the notes. We have already taught you this thing. That intensity depends on the square of amplitude, on the square of amplitudes. So if the intensity is reducing, the amplitude would also decrease, right?
So is there a formula that P over 4 pi r square?
V over 4 pi r. This one?
So P over 4 pi r square.
No, no, no. Not
Yeah, yeah.
yet. I don't think so.
Okay.
So I was saying, yeah, so if amplitude is decreasing, so yeah, maximum displacement would change. This is correct, right? We know that the maximum displacement means amplitude. So if amplitude is changing, so yes, maximum displacement will also change. Is this thing clear?
Okay.
So intensity and amplitude are directly proportional. So if the intensity reduces, that amplitude would also decrease. So yeah, it would change. A is correct here. The phase difference, no. Intensity does not change the phase difference. So all these points of phase difference are wrong. Is this question clear?
So could you repeat one more?
Intensity does not change the phase difference. It is also saying the constant frequency. If the frequency is constant, then the waves are in phase. So it does not change the phase difference. You cannot predict phase difference from intensity. They are not connected. That's why all these point of phase difference are of no connectivity. So that's why I'm saying that we can only predict the amplitude from intensity. We can't predict phase difference from it. Is it clear now?
Okay.
Now read this question.
The graph shows the variation with time of the displacement of an electromagnetic wave at a point. The wave is traveling in a vacuum. What is the amplitude and what is the wavelength of the wave?
So we know that we just for amplitude we will take this length and divide it by 2, right?
Yes.
So 3 plus 3 is 6, 6 divided by 2 is 3. So the answer would be A or C. And for wavelength, what we would do? We have to calculate. So we know the formula is V equals to frequency into lambda as the wave is traveling in the vacuum and it is an electromagnetic wave. So we know the speed is 3.0 into exponent 8. So for wavelength, it would be 3.0 into exponent 8 divided by frequency. So for frequency, we will take the how we will calculate frequency?
1 over t.
Yes, 1 over t. So it would be 20. So 1 over 20 into exponent minus because of this microseconds. Now calculate it and put it here and tell me that what is the wavelength coming. Quick. Sorry,
6,000.
just how the answer would be A. Is it clear?
Yes, sir.
You now read this question.
A source emitting sound of a single frequency Fs travels at constant speed directly towards an observer. The source then passes the observer and continues to move directly away from the observer. The velocity of the source remains constant, which graph represents the variation with time of the frequency Fo of the sound heard by the observer.
So what is happening first of all? Frequency h travels at a constant speed towards an observer. So if it is coming towards an observer, the frequency should increase or decrease.
It should increase.
It should increase. So yeah. So by passage or time, what happens? The source then passes the observer and continues to move directly away from the observer. So what is happening? The source is first coming towards the observer and then moving away from the observer, right?
Yeah.
So we know that first of all, what will happen? At first of all, the you can say the frequency would be greater, but after some time it would get
Yes.
lesser, right?
Yes.
So it would be not A because it is increasing. After some time, it should decrease. It would not be C as well. It would be either B or either D, right?
Yes.
So what do you think? See, in what is happening part B, that first of all, since the object was coming towards the observer, so the frequency was greater. But after some time, what happened? It passes the observer, so that it has
Mm.
started to decrease. That's what this question means. Now tell me, what is the what do you think? It will be B or D? And D, it is also happening same.
B,
Why B?
because it's starting at a constant high value and then
Yeah, you
it
can
drops.
say, see, this frequency would not change always. First of all, if have, it has passes you, then it would change. But in D, it is changing at all the time. That's not possible. So that is coming towards you, the frequency remains same. But after it passes you, it changes and then it remains same. That's why B is the answer. It would remain constant, does not change every time, right?
Okay.
Now read this question.
A transverse wave is moving along a rope. 2 points x and y on the rope are a quarter of a wavelength apart from each other. Which statement is not possible for the 2 points x and y at any instant?
Tell me what is they're saying that transfer wave is moving along a rope. 2 points x and y on the rope are a quarter of a wavelength apart from each other. So we know quarter means you can say half and then half. So something like it as well. So a question is which statement is not possible for the 2 points x and y at any instant? So they both are stationary.
Is it A?
Yeah, A, because they won't be stationary, right? The other points are they are displaced in opposite direction from the equilibrium position. Yes, they can be displaced in opposite direction. We have studied that if we make a wave from this point, So yeah, it is possible. It is coming upwards and can also come downwards as well. So they can move in upward direction. It is possible. So this point and this point is possible. They both have displacement of same magnitude from their equilibrium positions. So yeah, that is also possible that if we take from the equilibrium position, the distance could also be this distance and distance could also be same. Because this becomes 0.25 and 0.25 as well. This is possible as well, right? By D, they are saying that this is your equilibrium position, right? And if you're taking the 2 points, this one and this one, so yeah, the displacement from this point and from this thing, it would be same because they are a quarter wavelength apart, quarter wavelength apart. So you can say if we are exactly dividing the distance between them, right?
Okay.
Now read this point.
Two progressive waves meet at a fixed point P. The variation with time of the displacement of each wave at point P is shown in the graph. What is the phase difference between the two waves at point P?
Yeah, how will you calculate it for this wave? The phase difference between them. See, for calculating the phase difference between two different waves,
So first we
between
find the time period,
yes, for a time period, yes. What is the time period?
0.4.
0.4? No, it is C 0.2 and 1. So 1 minus 0.2, it is 0.8. Yes or no? Two consecutive first.
Yes.
Okay, so the time period is 0.8. So for calculating the phase difference, note this formula. We can calculate the phase difference between two waves. If it is given to us, the formula would be delta T over T multiplied by 360. This is the formula for the calculating the phase difference between two waves. Say, okay. So we know the time period we have calculated is 0.8, right? And for now delta T means change, or you can say difference in time period. So this way, if we calculate the different time period, for that we just have to take two consecutive thrust or trough for two different waves. If I take the crust of this wave, then I will be taking the crust of the another wave, which is this, right? And now tell me the difference between them, the time period difference. It would be 1 minus 0.7. Yes or no? For delta t, I would just take the consecutive crest or trough of two different waves. So this is the crest and this is the crest as well. So this would be my delta t.
Okay.
Is it clear now?
Yes.
Or you can take this as well, that consecutive of this one and this one. So it is also coming 0.3.
Mm.
So it's up to you. You just have to take the two consecutive crest or curve of two different waves. That's it. So it is 0.3 multiplied by 360. Now tell me the answer.
135.
1355. C would be your answer. Is it clear?
Yes, sir.
Okay, so let's keep the class till here. Now revise the notes and attempt some questions by yourself as well. I will take the class tomorrow at 2. I will confirm you later, okay, on test. But I might take it.
Okay.
Okay, so thank you.
Thank you, sir.